All right, let's talk about a piece of technology you interact with literally every single day, but probably never think about: the load balancer. Seriously, these things are the unsung heroes that keep the internet running, and we're going to break down exactly how they pull it off.
You know the feeling, right? It's Black Friday, or tickets for that massive concert just went live. You're hitting refresh, ready to go, and then, boom, the site grinds to a halt. It's so frustrating. And yeah, there's a very real technical reason that keeps happening. Think of it like this. A website is running on a server. That server is like a single toll booth on a highway. Now, if thousands of cars, or in our case, users, all try to cram through that one booth at the exact same time, you get a massive traffic jam. The server gets totally overwhelmed and just gives up. So what's the solution? Well, instead of one toll booth, what if you had a traffic cop standing in front of, say, 50 open booths, directing each car to the one with the shortest line? That right there is exactly what a load balancer does. It's our hero. It's the internet's traffic cop. So the basic idea is actually super simple. Instead of all of us trying to talk to one server, the load balancer sits in front of a whole group, a fleet of servers. It intercepts every single request coming in and says, okay, you go to server 1. You're going to server 2. Server 3 looks free. It just spreads the work out, making sure no single server gets buried in requests.
Now, these traffic cops come in two main flavors. On one hand, you have hardware load balancers. These are physical boxes, beefy, high-performance machines that are incredibly fast, but yeah, they're expensive. On the other hand, you've got software load balancers, like the super popular HA proxy. These are just applications you can run on standard servers, which gives you a ton of flexibility and is way more affordable.
Okay, so we know it directs traffic, but what does that actually accomplish? What are the real, tangible benefits of doing this? Let's get into its core superpowers. So it really has three main jobs. First, and most obviously, it prevents any one server from getting overloaded. Easy enough. Second, it's constantly running health checks. It's like a medic, always checking the pulse of the servers behind it. If it notices one is slow or completely offline, it immediately stops sending people its way. And third, and this is the big one, it eliminates the single point of failure. If one server dies, who cares? The load balancer just sends you to another healthy one, and you, the user, never even knew there was a problem. The site just stays up.
But wait, it gets even better. A load balancer's job isn't just directing traffic. It has some other really clever tricks that make the whole system more efficient and secure.
Yeah, you can think of the load balancer as the bouncer at the front door of a club. It can handle all the initial security checks so that the application servers inside can just focus on what they do best, running the actual application.
One of the most important security tasks it handles is called SSL termination. Now, all that encryption and decryption that makes websites secure, well, it takes a lot of computer power. Instead of making every single server do that heavy lifting, the load balancer does it just once, right at the front door. This frees up so much processing power on the back-end servers and makes managing security way easier. It's a huge win.
And beyond security, there's another cool thing they do to make your experience feel seamless and personal. They can actually remember which server you were talking to.
This is a feature called session persistence, and it is absolutely critical for things like online shopping. Imagine you put a pair of shoes in your shopping cart. You want that cart to follow you around the site, right? Well, the load balancer uses a little cookie to make sure that for your entire visit, you're always sent back to the exact same server, the one that knows what's in your cart. Without this, you'd click a link and your cart would suddenly be empty.
So load balancers sound pretty awesome, don't they? They stop crashes, they handle security, they keep our shopping carts full. But like any hero in any story, they have a weakness. There's always a trade-off.
And this is one of the great ironies of designing complex systems. In the process of fixing one really big, obvious problem, you almost always end up creating a new, sometimes more subtle, problem. And here is the paradox. Remember our goal? We added a load balancer to get rid of our single point of failure, that one lonely server. But what did we do? We created a new single point of failure. Because now, if the load balancer itself goes down, nobody can get to any of the servers. The entire site is offline. So this kicks off what we call a cycle of complexity. You start with one problem, the single server. You add a load balancer to fix it, but now it's the problem. So how do you fix that? Well, you add a second load balancer to act as a backup. Great, but now your system is way more complex to manage. So let's just quickly summarize these risks.
1. If your load balancer isn't configured correctly or isn't powerful enough, it can become the new bottleneck slowing everything down. 2. It absolutely adds a new layer of complexity to your whole setup. And 3, as we just saw, it basically trades one single point of failure for another.
This quote really hits the nail on the head. That complexity isn't a side effect. It's the cost of entry. It's the price you have to pay to get the amazing reliability and scalability that a load balancer gives you.
So, where does all of this leave us? With all these trade-offs, are load balancers actually a good idea? Let's get to the final takeaway.
Despite the paradoxes, despite the complexity, the answer is an overwhelming yes. Load balancers are an absolutely essential, totally non-negotiable tool for the modern web. You simply can't build a large-scale application without one. The problems they introduced are just the new set of challenges that engineers have to solve, because the alternative, having a single server, just doesn't work in the real world.
And that kind of leaves us with a bigger question to think about, right? If every solution we create just introduces a new, different kind of problem, what does that say about building things? Maybe the goal isn't to build a perfect system that has no problems. Maybe the goal is to be smart about choosing which problems you're willing to live with. Thanks so much for watching.